Start.
Yeah, sure.
Okay, that's great. So, okay, thanks for joining in. And obviously today what we're looking at is learning outcome 5 in particular, which is to look at discussing, this particular learning outcome, which is basically focused on understanding the future of computing. So where is it going? A word called quantum computing is what we come across quite often. And when we do talk about this word of quantum computing, AI, things which I read about or I basically go and see what is happening from a point of view of the technology advancing, or the future of where scientists are working on to create faster and more efficient computers. What are the terms which comes across as quantum computing? So we're going to be looking at understanding the future of computing. There are 3 assessment criteria. Obviously, this unit specification is slightly out of date. Even in 2024, when they introduced it, they have not mentioned things, or they have mentioned things which obviously we have now seen they are already already available in the market. So we'll look at brushing up in terms of what we see are the latest trends which are emerging in this market, and we'll discuss those as we go along. In the assessment criteria. So first part is to look at identifying future technology developments. So we need to know what, obviously, when you have the technology available, then it is something which is already in production and it is available for consumers to be able to use. But when we talk about future technology developments, what we are looking at is, for example, currently we see the Wi-Fi spectrum, or if we see advancements in the mobile phone, telecommunication, spectrum, we do see that 6G is currently being tested. And that is the technology which is not available to consumers yet, but will be available to us in the future. And that would be identified as a future trend. When we do talk about Wi-Fi, for example, Wi-Fi 7 is a technology which is currently under development, and this is what we would be looking at when we do talk about advances in future technology and its development. We would be looking at talking about things like data networks, which will be supported by faster speeds. And I know a couple of years back, I would say literally about 1 or 2 decades back, when we used to talk about Cat5 type cables, which is networking cables, but they used to be available from 10/100 Mbps. That means they would look at upload of 10 and a download of 100. But today we have 10/100/1000. We have gigabit Ethernet, which is available, and that is where this technology was in development at some point in time, but today it is available to consumers to be able to use. So future trends are going to be things which are under development, but yet not available to consumers. They are either in the conceptualization stage, testing stage, or in some sort of deployment stage, but not available. So we'll cover that here. Apart from technology, we can look at computing being used in smart cars, driverless cars. There are bits and pieces mentioned in terms of future developments like artificial intelligence. Like smart home speakers are now pretty much norm. You have Alexa, you have Google Home, you have Apple Apple AirPod or something like that, and these are already available. Your voice controlled cars, smart locks, smart lights. These are things which are already a part of smart home today. So you can have your heating being controlled by a smart home hub or a Nest appliance. You could have these things which are already now available in the market. So we will be looking at things beyond this in this particular assessment criteria. The second one talks about explaining the methods of researching new developments to keep up to date with computing development. So this is basically looking at dipping into, I would say, the research part of it that we covered last week, that how do you keep yourself up to date in terms of finding out what are the developments happening in this field. So like as a user, I look at tracking or look at different news channels like BBC News, Euronews, CNN News, and I keep myself abreast with what's happening in the world. But here, what we are talking about as an example is methods. That means you would probably do research online. You'll be part of forums. You'll be having some memberships. You'll go and attend some webinars or, conferences. You might be on a mailing list from the company, if you have a product, that there's a new product coming in or there's a new update coming in. So this is how we will be looking at updating ourselves and keeping ourselves up to date with developments happening in this field. So things that you can rely on. When I say research and methods, we are looking at reputable sources that you are going to be able to use to keep yourself updated. And the third one talks about how to, future-proof your computing system. So when we do talk about this as a assessment criteria, what we are looking at is trying to understand that how would we future-proof ourselves from a point of view of looking at using technology, wherein not just computing, but other forms of computing technology would be required. And in such cases, you'll be looking at, deploying technology in your organization, which would not mean that when you spend thousands of, hundreds and thousands of pounds to deploy a technology, that should be sustainable, that should be workable, that should be usable for a couple of years to come, rather than that technology becoming obsolete or defunct. So in such cases, use of components, systems would be done in such a way that they talk to each other. And as a system administrator, you would be looking at buying or investing into equipment which primarily is going to be, I would say, future proof. That means it is going to last you for a number of years at least to begin with, rather than you having to spend that money again and obviously look at let's say buying out new systems or investing into new systems from a finance perspective. So here you would take into account functionalities or features of the system that you're deploying, whether they talk to each other. Like, for example, what tends to happen is if I was a network administrator and I was looking at installing or buying, say, Cisco equipment, what I would then do is probably stick to Cisco, because my evaluations would have taken me to thoroughly test that system, see their capabilities, look at what is the future of the system, what are the future upgrades being introduced, rather than switching over to Juniper or any other form of network like Nokia or Ericsson, because that would mean that I would have to look at compatibility between the two, the firmware upgrades. And it's sometimes when software upgrades do happen, I might need to carry out them independently, which would need more time, effort, and money. So when you look at future proofing, you're essentially looking at scalability.
Ensuring a place, yeah.
That is
Ensuring
correct.
a place that, yeah.
Yeah, so you're looking at scalability and then workability of that particular system, for as long as possible, because that would mean you don't need to invest in the new technology or replace it entirely going forward. So these are the three assessment criteria that we will be looking at in terms of studying specifically when we do talk about, future of computing. This is the indicative content that we are going to look at in general. And when we do talk about some of the bits and pieces in terms of upgrades, so what I've done is I've actually put updated content here, which I think is more relevant from a point of view of today's context rather than what they have given across to us as indicative things to discuss. Now, very briefly, if we do talk about computing in particular, obviously we know that there are various other forms of computing technologies which are now becoming mainstream. We do see cloud computing already there. Cloud computing is being used increasingly to replace hardware that is utilized in local premises or a local area. But organizations, because systems and data is required irrespective of the geography or location, a lot of organizations have started to invest into what is called cloud computing. That means all the applications and software reside on the cloud, depending on what machine or device that you're using to access that data or get connected to the network. Then in such cases, those devices need to be compatible to be able to allow access. So for example, we use a CRM, and that CRM is actually running on the cloud. But as I'm using a Mac or I'm using a phone, I'm able to access that CRM application on either of the device, which allows me to run it, use it seamlessly without having to worry about whether the data server is in the office in the Manchester area or probably in the EU area. The other bits that we are looking at in computing, which are coming forward, are quantum computing, edge computing, and artificial intelligence. Now, even artificial intelligence is available today, and we see the most useful part of that, which we get to see and work with every day, is in intelligent or smart devices. So you see Nest Home Hub, you see your speaker, which is from Amazon or Alexa, as we call it. You see, for example, technology in your cars, in cars like Tesla or EV, electric vehicles which are coming. You see this in devices like smartphones, integration of Siri, for example, or Copilot in Microsoft, and Meta, which has brought out its own voice engine for WhatsApp and some of the other applications. These are all examples of artificial intelligence. Now, the basic part of it could be related to a voice-based system. That means it is able to automate your calling and act as a receptionist, but essentially that is a voice-based phone system that you have in the office. And when somebody calls, it is able to direct you to options. And with those options, you are able to essentially go to the right one to be able to solve a problem or, speak to somebody. But there is implications and obviously use of artificial intelligence or computing in lot many areas. We'll discuss that in the future slide, in the subsequent slides. Then you have quantum computing. Now, when we do talk about quantum computing, what we are looking at here is the quantum mechanics part of it is being leveraged to look at doing existential calculations. That means calculations which are required to be done, one, in bulk, and in complex situations, and calculations which are required to be done quite quickly or simultaneously, is the space where quantum computing is coming in. So quantum computing leverages quantum mechanical phenomena like superpositioning and entanglement, essentially, to be able to do or perform calculations than what classical computers do. When we talk about our computers or Macs that we use, they use normal computing wherein data is stored in binary bits, which is either zeros and ones. But quantum computing stores data in something which is called qubits or qubits, and they can exist simultaneously in multiple states. That is the big difference between classical computing and computational computing or quantum computing. So quantum computing is actually based on the principles of quantum mechanics, which basically govern that energy and matter can be managed at atomic and subatomic levels. In our case, obviously, we are managing in classical computing in the form of binary bits or zeros and ones. But in the case of quantum computing, you can manage it at the atomic and subatomic level. So there's a further smaller denomination of bit which is available, which is called qubit. And qubits are what the quantum computing computers actually use. So they are able to use qubits to be able to position data not just in zero and one form, which is binary, but it allows them to explore multiple possibilities by using qubits in quantum computing. And that is why qubit and quantum computing calculations can be done quite quickly. And quantum computer is very much faster than a normal classical computer. Now, today's application of quantum computing and some of the computers which IBM, Google, and Rigetti Computing, for example, have developed, they are used for solving, I would say, critical or very complex, problems. And they tend to be in cryptography, pharmacology, logistics, and financial modeling. So this bit we need to look at in the look at is in the context of, transactions which require, or I would say transactions which require more computing power. So when we look at Bitcoin and the generation of Bitcoin, is that a lot of computers are connected in a grid, and those computers connected in the grid give you the quantum. That means you are able to simultaneously harness the processing power of so many processors across the computing grid, which is basically computers connected peer-to-peer, PNP. And that allows you to do more calculations because it's like having a big processor, but that processor having billions and billions of transistors on it. But because that is not feasible and it is too expensive, so sometimes what companies would do is look at putting computers on grid by peer-to-peer networking, and that would allow them to carry out complex transactions. So quantum computing is basically based on that side, wherein it is looking at revolutionizing computing and calculations of complex transactions, because it is able to do simultaneous computations on certain transactions or computing transactions that are required. And that is where it is used for gene mapping, it is used for DNA splicing, it is used for, or probably is being used in material science. It is also being used to do or look at financial modeling. When you look at weather systems and the computers which are developed and deployed for calculating and predicting our weather patterns, that you are able to today see, okay, what will be the weather in Manchester 7 days from now, or weather in London 10 days from now. Now, this is all done using predictive analysis, and this requires supercomputing or quantum computing to be able to do so. And in such cases, you would find this application to be useful. Now, another part that we do talk about is what is called edge computing. So when we talk about edge computing, what we are looking at talking about is in terms of when we do say edge computing, we are basically looking at um, distributed computing model. That means in this case, in order to get, let's say, um, enormous amount of computing power to carry out certain calculations, or enormous amount of storage space to be able to store data or different types of data, thereby looking at building latency, or I would say reducing latency essentially in the retrieval of that data, you normally see edge computing being used. Now, edge computing, an example of that would be when you look at data servers or CDN networks, essentially, which basically hold and host multiple copies of websites so that your processing of retrieving data is faster. You would normally see some part of those applications could be using what is called edge computing. Now, edge computing, the difference between edge and classical computing is edge computing shifts the data to be not be centralized. It's the opposite of centralization. It will allow data to be stored in different locations. And that data stored in different locations would make it easier for devices, for people to be able to move data from one source to the other. But also when you're looking at, when I say moving, I mean shifting of data, but it will also make it easier for data processing to happen, because you would have that data being locally available in the closest possible network or closest possible server network, which will allow the retrieval of that data to be quicker. So when we look at edge computing is looking at shifting data processing from centralized data servers or centralized location to the edge of the network. And that is why it says edge computing, meaning it is moving the data closer to devices that would allow users to generate and consume information far more quickly than probably when it is available halfway across the world. So if I give you an example, like Google, for example, you have Google browser, you open that window up, and when you open that window up and you want to do a quick search on Google, sometimes if you remember a couple of years back, Google's data was all coming from central servers, probably in the data warehouse that they had. It could have been US, UK, Europe, or somewhere in Asia. Now, that meant that there was a bit of a delay in terms of opening the website or getting that data. But today, that data is stored across various networks and across various data centers by Google, which means that if customers are opening Google or using Google as a search engine to be able to search for something, that would allow them to retrieve data more quickly, which means data is going to be more closer to them from the device that they're accessing. And it's like saying, okay, if I do a Google search right now, I have a Google server in Manchester, which means the response time, the turnaround time, or the latency would be very, very slow. Sometimes you on the network, you look at pinging the network to see how long does it take in milliseconds for you to reach the server or ping the network. So if that data is available and residing in the local server, that would make it easy. Now, edge computing has various advantages. Edge computing allows devices like sensors, smartphones to basically locally store the data, but also retrieve data from their first local connected server, thereby reducing the amount of transit time required for data to be, like summoned. If you are calling somebody, data is summoned. Now, This is used in smartphones more often than any other device, because when you have smartphones, if you go back 5, 7 years, today we have 1 terabyte available on iPhone and Android phones. But a couple of years back, we had the highest capacity is 128 or 64 MB. So a lot of data, photos that you took, you actually stored on the iCloud or Google Play Store. And when you want to see those photos, they were cached into your device so that they can open quite quickly and you can actually flick through them. Now, this would have required the application like edge computing, because data is locally stored, data is available in real time, and data processing that happens is happening with a combination of your device as well as the localized server in your area. So it reduces latency, it improves real-time processing. It also, to a certain extent, requires lower bandwidth to be able to access data, and obviously increases scalability because more devices and applications can actually be connected to distribute the load of the application that you're running. And that allows those applications to be installed on central servers, and only a version of it is run on your machine like a client. And that allows computing to run and do these autonomous applications using remote servers or remote PCs and remote data, but you are getting the output of that on your device. So these are things which we do get to see, which are now being utilized in things like, when you have smart gadgets at your home, main processing part of it is happening it in the server, but a replica of that is transmitted in terms of end results to your device, which makes it easier for you to essentially use them as you use them in the house. So a simple example of that is if I have an Amazon Alexa speaker at home and in my room, and I say, Alexa, what is the weather like today? So the weather data and processing of what the weather is actually happening in the cloud server in the back, but that data is being pulled through on the smart device from the server, and it happens in milliseconds. It's able to say, good afternoon, Ramanjeet, and the weather in Manchester is like going to be sunny this week with a high of 19 and a low of 8 during the night. Now that processing is happening in the server, but the results of that processing is coming to your smart speaker or your Amazon Alexa. Now, when we do talk about cloud computing obviously is evolving. It is not something which is new today, but it is something which was available a couple of years back. But what we see is the cloud computing is essentially wherein your data is actually residing on the cloud. And when you call that data with regards to an application, or with regards to, say, for example, some sort of application that you're running, then that data is pulled through from the server in the cloud, and that is why it is called cloud computing. Now, there are lots of different types of services which are available currently: Amazon Web Services, Microsoft Azure, and these services typically provide data to you on any device that can be connected to that network, and they would provide you this data in very simple terms by storing it locally on the cloud, and then helping you retrieve that data through a software application which is deployed in the cloud or in the server itself. And that would mean that your device might just be a light end of a device, like having a client installed which will actually run that application. And when you close that application, the application would literally collapse or exit from your screen, but it is continuously running in the backend in the server or on the cloud. And that is where you are able to use the cloud part of it. That means a vast network of remote servers that store and process the data for you, and that would be something that we look at, which is called cloud computing. Now, if you were to look at advancements that are happening in the market, we are looking at artificial intelligence, blockchain technology, we are looking at it, and Internet of Things, and obviously extended reality. Now, we know that about 10 years back, a lot of companies started to introduce what are called the augmented reality headsets. But today, they are further advancements in that field, wherein you have virtual reality, and then you have the Vision Pro, which is nothing but spatial computing, which Apple has introduced, and Meta is also introducing through Metaverse. Now, when you look at these kind of developments which are happening, they are essentially technological advancements because they are available to you as a consumer today. So when you look at artificial intelligence, you have ChatGPT, which is an OpenAI application which they have created, and that pretty much allows you to do research, search information. And today, it is in a mode now that it will end up replacing your search engine, which essentially at one point in time was Google. But today, that search engine
Yeah.
by default is now becoming either Claude, Perplexity, or ChatGPT. So people prefer to do a quick search on ChatGPT because it does not just give you the results or brings you the results, but it also explains what these are and then gives you the details of it. So you'd look at Bitcoin, which is cryptocurrency, which basically has enhanced security. That means money cannot be stolen. If a transaction happens, it gets uploaded to all the servers connected on the net grid or the network, thereby ensuring that traceability and transparency is there. And money cannot be stolen. So if you buy something using cryptocurrency, it will actually create a record not just on the server, but all the PCs which are on that network, so that if one record is to be deleted by a hacker or somebody else, you can still balance that record or get that record from other PCs or any one of the PCs. So Internet
Mm.
of Things is devices which have internet accessibility like smart TV, your smart home, your smart speaker, and they are able to exchange data and provide information by using any sort of commands, voice commands or vision commands, or any sort of
Mm.
gesture commands in some cases. Now,
Regarding the AI, yeah,
yeah, go on.
regarding the AI, what is the measure that guarantees that it's reliable enough, the information is true and it's correct? I know it might be outside of the topic, but like always
But
wonder, like sometimes maybe it's not the right information.
so when we do talk about reliability of AI, what we are looking at is, in most cases, these language learning machine models, or LLMs as we call them, they are essentially having information to a certain date. And because it learns from uh,
Our questions.
I would say it learns from experiences, essentially, and what the users are asking it, and then it assimilates that data into its own database or a central database. That is where sometimes you have to specify that, AI, this is a information produced by AI may not be 100% accurate. But generally, when you look at OpenAI and OpenAI's engine, the temperature, the condition of it, which you define in terms of when you install it and when you start using it. It also defines how the AI would actually interact and obviously understand your commands and provide data or requests that you're asking for in return. So, in the context of AI, I would say reliability refers to the system's consistency and accuracy in terms of producing results. Now, this would vary under various conditions. So, depending on what function and what products and what information you're asking, if the engine has not been configured to say, for example, have data. Like when ChatGPT was introduced, it was trained up till 2021, September 2021. Then slowly and gradually they released an update. It brought it up par to 2023. Currently, the engine is powered up until September 2024. So any information that you're asking from ChatGPT will be all previous to the information which has been either published, occurred as an event in or before September 2024. So here the context of reliability would be related to, I would say, compliance and also data protection, which would make sure that any any data which AI is actually giving you would be related to a particular timeline. And in some cases, that would be related to, for example, I would say any sort of algorithm which has been built into the model for up until a certain date or time. So anything beyond that, you would probably be looking at testing the system in terms of it's the data that it serves, and you would be required to obviously look at doing continuous monitoring in a certain extent to ensure that the data being produced is genuine and accurate. That's why sometimes when you do prompting and when you're asking ChatGPT, Claude, some of these engines like Google Gemini to provide you information, Google is saying that my engine is going to be obviously providing you information from the web, and it will also provide the sources from which the information is coming. So
Mm.
one of the things which is becoming important in terms of reliability for AI is that the AI should also be able to provide sources from which it is picking out that information. And Google's Gemini is doing that. But ChatGPT
Yeah,
currently does not give you the source from which this information is coming. And that is where sometimes the reliability of that information being produced by ChatGPT is questionable.
yeah, I understand
Okay.
now.
So sources is something which Claude, Perplexity, Google Gemini, I think they have started to build in. So if you ask for any information, then it will give you a bit of a reference or a related website or something which will allow you to click on it, taking you to the source, which would that mean that okay, you're able to see the information, but you're also able to verify the source, and that's where it becomes reliable. Now, there are
Yeah,
lots of implications of it that we will understand in terms of, advancements in computing technology. There could be societal and economic implications. So, for example, one of the reports from Deloitte and Touche actually says that AI is going to eat away or take away about 70 million jobs by 2030. But it also
yeah,
predicts that it will create 25 new million jobs, which will be required at a higher level. That means people who understand coding, people who understand prompting, people who understand how AI can be integrated into other applications. So it could have significant impacts on employability across the world, and that would depend on in which country, in which city, in which application or type of area the AI is being employed or deployed, and that would have an implication as far as job losses are concerned. Now, in healthcare, obviously, advances in computing are enabling, personalized medicine to be delivered, diagnostics to be done, and obviously a new upcoming field which is called telemedicine. So people are able to log into the internet and meet somebody as a virtual doctor, and that allows the database to serve information depending on the symptoms and the questions being asked and answered by the patient. The other thing that telemedicine also does is that it allows doctors in one location or medics in one locations to be able to actually offer advice and, for example, treatment from across the globe, because telemedicine allows electronic information to be stored, and using systems, telecommunication and healthcare systems in particular, which are used within this sector in medication, patient care, clinical interactions and diagnosis and treatment can become easier or faster. So you would not need to wait, obviously, and in some cases, this concept that allows treatment and monitoring of the treatments to be done in a far quicker way because you're deploying technology like cameras, teleconferencing, internet, or broadband to be able to limit distance as a factor, which is going to be an innovating factor to be able to provide those services. So I am sitting in Manchester. I can provide, through using medicine, use of cameras and equipment remotely available and broadband, I am able to connect to a hospital or connect to a location and speak to the patient and obviously provide assistance as against being physically there. So those bits you are understanding, which are going to be helpful to society in general. But sometimes, you'll have to look at pros and cons, and in such cases, remote mirroring, remote monitoring, looking at cost efficiency or improved efficiency would be the important aspects of AI or computing actually improving and the use of technology actually improving, let's say medication in this side or treatments in this side for patients.
mm,
Now, there are obviously lots and lots of different types of, I would say,
aspects.
advancements which are happening. Now, there is
Yeah,
something called neuromorphic computing. Now, neuromorphic computing is basically emulating neural structures of human brain to create highly efficient and adaptive AI systems. To a certain extent, we see this in spatial computing simply because when you look at the Apple Vision Pro, when you put it on, it focuses your eyes first to a particular, it focuses your eyes essentially, and then it uses the gestures to be able to help you control and command certain applications and or work with certain applications during that. So, for example, in Apple Vision Pro, if you move your hand like this, you're able to have some gestures controls. If you look at the Meta Ray glasses currently, if you wear them on, you can increase the volume by sliding onto it. If you want to shift your iPods and you want to move to a different song or previous song, you double tap on it and it will obviously do this. So this part is actually utilizing human brain and the signals which the human brain uses or communicates through our senses, like eyes and hands and bodily gestures, to be able to control what are called applications. And they are what we get to see in neuromorphic computing. Sustainable computing is basically looking at how computing and usage of computing in terms of usage of power, heat generation, and how to make them data efficient is being kept in mind when we look at sustainability or sustainable environment. Now, if you imagine when you look at a company decides to put up a data center. Now, Facebook has decided to put a data center in Sweden, for example, or in the Nordics, is primarily because data centers have thousands and thousands of computers connected in grid. Now, when these computers are connected in the grid, they are utilizing energy, but they are also dissipating heat and, let's say electricity, which is being used, and then obviously they are dissipating heat as a byproduct. Now, if these computers are required to be cooled at some temperature to keep them working 24/7, then in such cases, it is utilizing higher amount of electricity to be able to keep them running and keep them going. So in such cases, when we do talk about sustainable computing, what we are looking at is computers which are environmentally suitable, sustainable, and do not drain the natural resources. In this case, in terms of when I say natural resources, what I mean by that is efficiently utilize electricity, because more utilization of electricity would mean that at some stage, somewhere, the electricity is being produced in the grid, is being produced in the hydroelectric dam or nuclear energy, and that is requiring its own process of production, which means that sometimes you have more cooling which is required, and that is contributing to global house warming. So in such cases, you would look at sustainable computing. I should literally change 5G to 6G here, because 6G and beyond, you have Wi-Fi 7, you have 6G connectivity, which is now coming in. And these are innovations now being introduced in this field, which would allow faster connecting, quicker connection time, faster download speeds. And they, I would say, essentially are developments which are going to shape up modern computing. So this, in a nutshell, actually provides you an example of where you would find, future computing trends as far as developments and enhancements are concerned in this particular field. Is that okay?
Yeah.
Now, for the balance part of the assessment criteria, because we are addressing it in detail, I have produced some slides individually, which will primarily go into a bit more detail here. And that is what I would suggest that you need to read so that you are able to grasp on the individual assessment criteria. So 5.1
Yeah.
talks about identifying future trends. We've spoken about quantum computing, artificial intelligence, neuromorphic computing, extended reality, 5G and beyond, which is 6G. So there are some slides which are there, which I've created one slide each, which basically talk about, what is the advancement and where they are going to be potentially used. So this is
Mm.
what I would suggest that you read, offline. That will give you a bit more detailing on what they are talking about in terms of advancements which are happening in certain individual sectors or fields that we talk about related to assessment criteria 5.1. And here I've summarized these advancements in a table by telling you what the technology is, what could be the potential development, and what would be examples or which companies are essentially, building these going forward.
Yeah.
Okay, the second part is again going into details of methods of researching. So here, if you recall from yesterday when we did talk about, in terms of how you would keep yourself up to date in terms of developments which are happening. A lot of people in the IT side subscribe to industry journals and some sort of publications and have memberships. These memberships, publications, and seminars or conferences that you attend typically allow you to keep yourself up to date with how developments are happening in this particular field. So some of these that you can recap are one, like I remember a couple of years back when Microsoft Server was being deployed in the organization, Microsoft Server side of team also had what is called the MSN network. So they used to regularly come out with yearly updates on Microsoft Server and the software, which meant that they used to send you CDs and manuals or updates when they were being produced. So that was one way of keeping myself up to date with what was happening on that side by looking at subscribing, because we had bought the original software, and that meant you had taken 3 years subscription on support on it, and which meant that Microsoft used to send these things to you in the post. Now, obviously, attending conferences or keeping yourself up to date with attending conferences or having industry memberships of certain bodies would allow you to keep yourself updated. Then you are looking at, obviously keeping yourself updated with certain websites and, RSS feeds that would basically publish new, say, updates. Sometimes what happens is when new updates are published and peer reviewed, these updates are or tech advancements are peer reviewed. They are published in a certain website or journals, and if you are subscribed to that website, you get alerts to say this has been introduced or this is the update which is happening, and that allows you to keep yourself up to date with developments happening in this field. Professional associations and organizations. So a lot of people who do the IT course also take up the British Computer Society membership or BCS membership. This membership is basically an association with the chartered body, which I mentioned here. There are other bodies across in the world, and depending on what field you're in, you would normally have a membership which would keep you up to date with regards to some CPD events, some reading material that they send. They send some magazines or collaterals, normally through the post and emails, newsletters, and they keep you updated on whatever the developments are happening in this particular area. So there's a table that I've created. Obviously, that table summarizes and gives you a summary of how you would generally keep yourself up to date with developments happening, in the field, and they would be something that you need to know because that is related to your assessment criteria 5.2, saying explain methods of researching new developments to keep yourself up to date with computing or developments
Yeah.
happening in computing. The third one is talking about future-proofing computing. So here, I would suggest that sometimes as a system administrator, when you do shortlist technologies for deployment in your organization, you have to keep in mind that anything that you choose is actually scalable and flexible. That means it is able to work with other networks or other types of architecture. Sometimes, and I gave you an example earlier, that when networking equipment is bought, it is bought in the sense that the company would thoroughly do research on understanding what are the various types of devices which will be connected on the network, and do if they have to change, replace, or buy any other type of device from any other provider or any other manufacturer, then will those devices be integratable into the network? And they would be devices like routers, switches. Sometimes you have devices which could be softwares, and they would need to be compatible in terms of working with your existing terminals, devices, PCs, servers within the organization. And that is
Yeah.
where,
So,
hmm,
yeah, I'm sorry. I just wanted to say that when you say proving, you mean like adaptability?
yes, so when I say future proofing, what I mean essentially here is that, as an IT administrator, you're given budgets every year, or you have certain amount of budgets to be able to buy, purchase, upgrade system hardware or configurations that you want to deploy within the organization. So when you buy something, we want to future proof yourself. That means you want to be able to make sure that your dollar or your money that you're spending on a technology travels the farthest. That means it is able to last for as many years as possible. So future proofing would mean, if I was looking at, as an example, buying something today in the organization to install, for example, I was looking at buying a router, then I wouldn't buy a router which will be 802.11b compatible. I would buy something which is the latest technology, which is 801, 801.11.n network, which has the fastest speed or the sixth generation and can also support seventh generation of Wi-Fi speeds. Now, one part could be looking at, because I'm trying to buy a hardware, I need to replace some of the others. But today, if I'm buying, I'm looking at buying something which is latest. But there could be situation in your network wherein your network and your routers would only support ABG wireless standards, right? Which is up to 55 gigahertz speeds only. So that would mean if you buy even buy one router which is N standard by default has faster speeds, that would mean it will still work at a lower bandwidth with some of the other infrastructure which is installed in your premises. But what do I mean by future proofing there? Is that today, if you're buying something as an equipment, you are updating and buying something which is up to date and in time and in tune with what the requirements are. Because tomorrow, at some stage, you would need to replace your older equipment, and you're not going to buy equipment which is going to be ABG compatible, but buy equipment which is going to be N compatible. So, future proofing
Yeah,
is making sure that the equipment or the money that you're spending will last you for as many years as possible.
yeah,
Then you want to buy, or invest in equipment or devices which would have regular updates. So when Microsoft announces that they are closing updates for Windows XP or Windows Vista, that means those operating systems are no longer going to be supported. So as an organization, you would be faced with a dilemma that whether we need to, although they are working and employees are happy with it, but do you need to replace it because any new vulnerabilities or any problems which come in those systems will not be supported by Microsoft. So in such cases, you want to buy, invest, and use that technology which has regular updates and say for example technical support available for a number of years to come. So in such cases, buying an obsolete technology or software which we know will be end of life soon, you would probably not want to invest in that because it won't be supporting upgrades or any sort of, say, firmware upgrades or upgrades coming into the software itself or hardware itself. So people used to buy network cards to be installing on PC. The network cards used to be 10/100, but today network cards are 100/1000. Now, if you have a motherboard on your PC which is only supporting 10/100, that means even with an upgrade which is available software wise, hardware wise, you would need to change the motherboard. It won't support gigabit, Ethernet card. So in such cases, if companies buying a PC or PC related infrastructure, they would need to buy something which is, being going to support newer versions of the operating system and the software. The same case, so you need to think of areas, and when you think of these areas, you would need to look at ensuring that when you're buying something, when you're investing in something, when you're upgrading to something in terms of technology, that would be that is going to be usable for a number of years to come. So in such cases, it would mean that you need to look at ensuring that one, you're continuously investing into something which is updated and investing into something which is the most up to date in the market, because in this field, things upgrade and change quite quickly. Now, if you look at the iPhone, it was brought out in 2007, and today we have iPhone 16. So in about 10 years, 15 years time, if you look at 2007 to 2008, 17, and 2025, in I would say roughly about 17 years, you've seen 16 different versions of the phone which is available. So if you had the old phone, it was still working with 2.5G or CDMA technology, it will work, it will not work today. Obviously,
yeah,
longevity wise, the life cycle is also there for the product, but just as a very generic example, not literal, is that those devices will not work on today's network. So that is where at some stage when you had near field technology or near field communication, NFC being included, today you don't need to carry a credit card on your phone or with you. You can actually copy a soft version of it on your phone, and that will be something that you can use through NFC to be able to make payments up to £120 in any place across the world on credit card or any sort of machines. Now, this means that your device, if you bought something like an iPhone 10 or iPhone 11 or so, or iPhone 12, I think NFC was introduced in iPhone 11, you would still have that device working today and be able to make payments electronically using that device. But if you have an iPhone 10 or iPhone 8 or iPhone 6, that won't work because that technology is not there supported in that model. So that is where you want to implement something which is, or you want to upgrade your phone and you want to invest in something which is going to work in the current modern times. So looking at certain points, like when you look at buying something or buying a software or upgrading your system, you're also looking at cybersecurity policies or practices to ensure that the device is going to remain a robust device in terms of security. That means it will not allow or have any gaps in security in terms of software, which would allow hackers or other potential malware software to exploit those vulnerabilities. And in such cases, you would generally see that biometrics, or initially on the phones we had a four code security button, but today you have six code security code available on the phone, which is difficult to crack. Then you are leveraging open standards and interoperability, which essentially means that your device is able to get information, fetch information, store information across devices and platforms, right? Now, if I give you an example here of interoperability, you cannot have Google applications installed on the iPhone and vice versa, because they are part of two different operating systems. One is Android, the other is iOS. But when you look at Windows and when you look at Linux and when you look at Ubuntu, these are companies which are producing operating systems and they do not allow interoperability. But on the Macs, for example, if you wanted to use Windows, you could use and install Parallels as a software, which will allow you to run Windows-based applications in that environment, right? So that is interoperability. So interoperability essentially is going to be useful provided you are able to see multiple systems across the network. People are familiar with Mac, people are familiar with Windows, but both the systems can connect into your network and get access to Wi-Fi, printing, and other system managed services. That would be interoperability. Now, we can also discuss lots and lots of different types of ways that future proofing of technology can be done. And that's why I've looked at putting up this table. For example, staff training is one of them. Making sure you're having plans to be able to mitigate technology or risks that can be faced in terms of technology. And that is where you look at backup systems or disaster recovery systems. And today, one of the key things with most organizations is sustainability. So any new deployment of systems, assuming if the organization was looking at deploying 2,000 computers, I think the organization would be looking at taking a decision, I would say, to allow its own users to bring, employees to bring its own device, which is bring your own device kind of a policy, so that you don't need 2,000 PCs to be invested on in terms of energy utilization and other things. So if there are so many employees which work within that organization or the office on a particular day, they bring their own device, and that is more going to be system efficient and sustainable, with some policies and practices implemented on the device with regards to sharing and having the information. So in such cases, you would look at developing systems which require less power. They are more energy efficient, they have more backups, and obviously, when you look at buying a phone today, one of the key things which users are looking at is they are looking at the aspect of ensuring that it has more processing power, it gives you a longer battery life, and it has more storage. And that would be one way of evaluating sustainability from an energy oblique storage point of view from an end user perspective. And that could be another way of looking at, if you were to go out and buy a phone today, you would not buy a phone with 64 GB or 128 GB storage space. You know that it gets filled up quite quickly. So you'll probably look at minimum of 128 or 256 as against buying something like 32 gig or 64 gig. So that is future proofing your requirements, because today when you take a photograph from a 48 megapixel camera, each photograph image size stored on the phone is going to be 3-4 megabytes or 8 or 9 megabytes. And in such cases, if you have low capacity on the phone or 128 gig, that means your phone space will fill up quite quickly, and you'll need to buy additional iStorage or iCloud storage.
Yeah.
Is that okay? So
Yeah.
this brings us to the end of discussing these particular assessment criteria. Now, towards the end, what I've done is I've written and included certain topics that I would suggest that you do a bit of further reading in. So these are topics which will give you a background in terms of, if I was to look at where computing started and where we are currently, one of the reading articles is Computing Looking Back and Moving Forward. The other one is Modern Computing. The Third one that I've chosen is Tech Trends 2025 by Deloitte. This is something which is a very useful report created by Deloitte in terms of explaining how the evolution of future systems or technology is going to happen in computing. And then we have future of computing, and then future of computing depends, which is again an article in terms of context to computing models or computational models in computing. So this would be the additional reading that I would suggest for this particular learning outcome, which is understanding the future of computing. And it'll give you a thorough knowledge of how technology is changing, what developments are happening, and where are we moving with regards to looking at this particular field.
Yeah.
Is that okay?
Yeah.
Any questions on this so far?
No, it's clear. Everything is clear.
Okay, good stuff. So what I'm going to do is obviously, mention one or two quick videos as well, specifically on the aspect of, on the aspect of, quantum computing and why it is going to be a game changer. So this is something that I would suggest that you look at, reading or watching in particular, because these are YouTube videos produced by companies like NVIDIA and, ARM or Google, which are essentially, making advancements in this particular field. So if I look at quantum computing, that would be NVIDIA's upcoming, quantum computer, which is going to revolutionize gaming. That's the video that I would suggest that you need to watch. And there are lots and lots of different types of, systems which Microsoft is currently working on, which basically talks about, topical quantum computing. And that could be an area of interest if you want to look at about quantum computing in particular. Then this is another video that you could watch, which Microsoft is working on, and they would be quite useful for maybe increasing your knowledge on some of these fields.
Yeah.
Okay.
Thank you, Mr. Rahman.
No problem. So I'll get a copy of uploaded, uploaded version of this presentation available on Moodle shortly. What I've also done is that I have also switched you over to the new system. I'm not too sure whether you've looked at that or not on your end, but there will be logins that you will receive, to the new system. And that new system, just very briefly showing you, has everything on it, what you typically get. But along with that, it also has videos that we have created on some of the learning outcomes, which are different from the live tutorials that we are doing. So let me
Yeah.
just show you a second. So this particular system is on a new domain, which is called IFA ukversity.co.uk. So when you do look at getting the access for this, your course, which is computing, will be under ATHE and level 3 diploma in information technology. And when you go in, what you're going to see is the units that we are studying. So when you click on the left, you are going to be able to see all the material which is there for this particular unit.
Mhm.
Right? An introduction to cybersecurity. What we've done is we've got our own videos that we've created, which have been uploaded learning outcome wise. And these are
Yeah.
videos that you are going to see, which will start coming up for emerging technology and digital technology as well.
Yeah. I
Okay.
understand.
So
Yeah.
you are enrolled on
I'll
this.
find this at Moodle.
Yeah, this is on Moodle, but you're enrolled on the newer version of Moodle now. So essentially, what you will need
Yeah.
is log into this to be able to access the Moodle. So I will send you a login for this particular system just after this session. If you haven't already received it from Andy, then that will allow you to switch over to this system, and the old one will get discontinued after a certain amount of time.
Yeah. Thank you, Mr.
Okay.
Rahman.
No worries. I'll send the link over to you on WhatsApp so that you're able to, know which URL has the system on it, and that would allow you to essentially, get onto it.
Yeah.
Okay.
Yeah. Tomorrow we're gonna discuss the assignment brief.
Tomorrow we are going to discuss the assignment.
Yeah. Okay.
Okay.
What time?
Tomorrow, we'll do.
Do you have any
Tomorrow same
idea?
time, 2 o'clock.
2 o'clock. Okay. Thank you, Mr. Rahman, very much.
No worries. Take care. Thanks for
Have a
joining
nice
the
day.
channel. Take care.
Yeah.
Bye.